Hello guys, we're going to take another look at the Volvo A40D this week. In the last video, or well 2 videos ago, I got the little control board here. We have one TB6612F&G motor driver on that, and I had it driving all 6 motors, so we have 6 wheels and 6 motors. And what I'm going to do in this video is give each pair of wheels, each left and right set, their own individual TB6612F&G motor driver. And hopefully that'll allow us to get more power to each individual wheels. But the way I'm going to wire it is so that the motors can have a higher voltage than the control board, which is something that you can't do with this little board. This was designed for 3.7 volt batteries and that was it. But if we give each individual pair of motors their own motor driver, then we can interconnect all the control wires and put a larger wire running along the power line, so the positive for the motors and the grounds. So by providing wires for the motor drivers themselves, we can then try first at 3.7 volts, then 2 batteries for 7.4 and 3 batteries for 11.1 volts, and that way we'll be able to see what the motors perform like at all the 3 different voltages and find out what's the best. It's not that big of a job to put 3 of these batteries in here, and probably it would be best to give the control board, the Arduino, then its own 3.7 volt battery. That way the power being drawn by the motor drivers will never affect the Arduino supply voltage, because it has its own supply voltage which is kind of isolated. Our motor drivers came with all this header, so we don't need that. We'll put that in storage and we'll use it in another project later on. And if we take a look at our motor drivers here, we can see that we have all the markings of what each pin is on the back of them. So we have our PWM pin for channel A, then we have A in 1 and A in 2, they control the direction. PWM B and B in 1, B in 2, they are for the second channel on each motor driver. So one channel, we'll say channel A is going to be the right hand side wheels and channel B will be the left hand side wheels. So we'll wire all the channel A control pins on each motor driver together. So that means that we'll only have 3 wires at the microcontroller for channel A, and the same with channel B. That'll leave us with just 6 wires to control all of these motor drivers. But each motor driver will only be controlling 2 motors, so each channel will control 1 motor, and that's what we're trying to do here. Then we can put a heavier wire on all the VM pins, that's the motor voltage pins, and that'll allow us to give a higher voltage to try the motors out at different voltages, see what works the best for us. And then VCC, we'll supply that from whatever power source is supplying the microcontroller, and the grounds will all be connected to the microcontroller and everything, because you have to have the grounds connected in order to get the signal wires to work. So I have quite a bit of rewiring to do here because I had all the motors wired in parallel there. So I'm going to have to split them all up again and put new wires in so that I can add in these motor drivers. So that's what I'm going to do now, and we'll skip ahead to that point. Okay, it's a few hours later now and I finally got everything wired up the way I want it. On the back here we have our 2 motors coming into one of the motor drivers. I actually 2 motor drivers here stacked one on top of the other, and I just soldered them together with some header. So all the wires then are connecting to these 2 motor drivers here, and the signal wires are coming along. The power wires that I've used here are way heavier than they need to be because the traces on the board wouldn't be able to carry as much current as those wires, so probably I should have used smaller wire there, but anyway, that's what I did. And the 2 motor drivers here, the signal wires all come up to one in the front here, which is connected to the front 2 motors. Now what I've set up here is I have the 2 wires coming out to the battery that we're going to change the voltage of to test, and everything else I have set up to, all the signal wires are coming here to this 3.7 volt battery, and that's set up so that the model is going to drive forward all the time. So what I'm going to do, instead of starting wiring everything now, because it took me a few hours to do this and I have other things to do today, so I'm going to just leave it like this for today, and we'll see what we can pull up a hill just by testing our, or changing our voltage on our battery here. So we have our 3.7 volt batteries, and we'll just change the connection here, change the voltage, and see how much can we actually pull with this model in this current configuration. That means using just 3.7 volts here we'll be able to compare this setup with the 3 motor drivers to the one we tested in the previous video, which had the single motor driver, and we'll see if there's any difference. Other than the rewiring, there's not a whole lot has changed here. I've removed the servo, but I don't think that weight is going to make any real difference because the load in the bed of the truck is way heavier than the actual truck itself, so don't think that'll make any difference. But we'll be able to see if our new setup here can pull up the hill, and if it can't, at what voltage it will be able to pull up the hill. Okay, so once again we're set up here ready to go up our ramp, and I've weighed it. It's around about 1.6 kilos this time, so we'll see if it can carry that up the hill. We'll start off with the 3.7 volt battery test. Hopefully the model will go reasonably straight up the hill, because obviously we've no steering. I took out the servo, so let's just give it a go and see what's going to happen. Just like what happened last week, we are spinning our wheels. The 2 wheels in the middle, they're taking all the weight, and the other 2 sets of wheels are just kind of floating in the air, so they're spinning. So adding individual motor drivers didn't really help us there. Maybe what we really need is some sort of suspension system, so that when we get to this point where all the weight is on these 2 wheels, that they kind of push on some springs up a little bit maybe, and that might let some weight get down on the other 2 sets of wheels to pull it up the hill. But like I said in one of the other videos, when the scenery is kind of in its position for display, this area would be full of gravel, so we wouldn't actually have to climb this hill. But I'd still like it to be able to do that. So let's go for the 7.4 volts. It's getting a little hard to control now because it's going quite fast, but it did kind of get up the hill there, but I'm not sure if I pushed the front wheels down, so let's give it another go. So it looks like the 7.4 volt battery gives us more than enough power to push up the whole weight of the model. We were obviously again still putting all the weight on these 2 wheels, but this time they were able to push the whole model up. So it's getting a little fast now, a bit hard to control, so I might come up with some way of fixing the steering before I do the next test, because it could just shoot off into the wall, which is no good. Okay, well I might have got the steering to stay straight. Let's test it with the 7.4 volts. So the steering stayed straight, but it looks like the 7.4 volts wasn't able to pull it up this time. We must have got a better run at it last time, so let's give that another little go here. So it looks like the 7.4 volts might not be able to pull it up after all. I don't know how it got up the first time. So I guess we just got lucky with that 7.4 volts the first time when it climbed. Let's give it full power now and see if that is consistently climbing. Okay, with the 11.1 volts I think it is, it absolutely flew up the hill, so let's give that another go. It's so fast that we probably are risking breaking the gearbox, to be honest. So that has no problem getting up the hill with the 11.1 volts, or I forget what it is fully charged, but I think it's about 11.1 volts when it's kind of discharged. So when we add the microcontroller, we'll get the variable speed on each side of the motor. So the left and the right side will have individual speed for our steering, our kind of software differential type thing. So once we have that, we should have much better control than we do at the minute, because at the minute it's just kind of, you know, I'm just putting full power here to the motors and it's just going flat out up the hill. So we're kind of running into the walls and running into everything. But once we have that, and we use this 11.1 volts I think we have set up here, I'm pretty sure we'll have no problem climbing any hill with the model. I think we'll need to strengthen up the axles though, because they seem to be bowing up a bit at the front anyway. So that needs a little bit of improvement. Maybe the 3D printed material is just not strong enough. So in the next video I will add the microcontroller and we'll get some PWM control of these individual motors. And I think when we've got to that stage our model is going to be pretty much ideal. I don't think we'll need to do a whole lot more in terms of the drive of the model. I'd say we'll have the control. Once we have the PWM we'll have really good steering because we'll be using that software differential thing, and then with the 11.1 it looks like we're going to have enough power to pull even a fully loaded truck around. So if you liked that video, make sure and hit the like button, and if you have any comments or suggestions let me know below the video. Head on over to the forum, and I think that's pretty much everything, so thanks very much for watching.